This is a second example on using a method of proportions to find an equation of an exponential function if you are given two ordered pairs on the graph of that function. Find the equation of the exponential function whose graph contains the points 4, 12 and 10, 5. Round your quantities to the nearest hundredth if necessary, but only round in the very last step of the problem. I encourage you to pause the video, try to work your way through this problem, and then restart the video and check your results against what I get. Use the exponential model y equals ab to the x. We will plug in the points 4, 12 and 10, 5 individually to make two equations. 4, 12 gives us 12 equals ab to the 4th. 10, 5 gives us 5 equals ab to the 10th. We'll take those two equations and stack them in a proportion. I usually put my equation with the larger exponent or the greater exponent in the numerators. Once you're here, you should notice that the a's are going to cancel out, and then you can work on reducing those b quantities with the properties of exponents. You'll get 5 twelfths equals b to the 10 minus 4 from the properties of exponents. That means that 5 twelfths will equal b to the 6th, and we need to isolate b. To do that, to undo the 6th power, we'll use the 1/6 power. We'll apply that to both sides of the equation, and then we have some calculation to do to get the b value by itself. If we come over here to the graphing calculator and check out this calculation, you can use parentheses, 5 twelfths for the base, and we'll raise that to the 1/6 power. If your calculator keeps that exponent portion all in the exponent location, you can use no parentheses up there in the exponent, but it's safe to put them in anyway. When we hit enter, we'll get a b value of about 0.864, and it goes on from there. We're going to leave this just sitting right here on the calculator. We're not going to do any rounding right now. Oh, sorry. So I'm just going to record that b is approximately 0.8642. To go ahead and find our a value, now that we know b, we need to select one of the original equations to work with. I'm going to select 12 equals ab to the 4th, but the other equation would be fine as well. I'm going to substitute in my understood b value, the one that we just worked so hard to find. So I have 12 equals a times that long quantity raised to the 4th. I use those ellipsis dots on the end just to indicate that I know that I haven't done any rounding yet. To solve this equation for a, we're going to have to divide by the quantity over here with the parentheses and the exponent on it. We'll divide both sides of our equation by that. When we do that, we'll get the a all by itself, and then we have a long quantity that needs to be calculated to find the a value all by itself. Over here on the graphing calculator, we can do 12 for the numerator divided by our previous answer. That'll use the quantity that we found for b, but that needs to be raised to the 4th. And then tell it enter, and this is what our a value ends up being. So a is about 21.5107. Now that you know the a value and the b value, we can construct our equation for our exponential function, and we can do the rounding right now. We would get y equals 21.51 times 0.86 raised to the x. There's our equation again. According to this statement, our equation, the y-intercept of the graph should be at 0, 21.51, and the graph should decrease because our b value is strictly between 0 and 1. Taking a look at a quick sketch of our original points, 4, 12, and 10, 5, and putting in an exponential function between them, we do see that the graph decreases from left to right. And looking at this graph, we can see that the y-intercept is a bit above 20, and so our y-intercept is reasonable. In order to check your work more specifically, you could plug in your original points into the equation that you just came up with. Do those one at a time and make sure that you get statements that are true. When you have rounded the coefficients like this, we might not come up exactly perfect. Another way of checking this would be to use your two ordered pairs that you started with, 4, 12 and 10, 5, and use exponential regression on the graphing calculator to see if you get the same coefficients.